Okay, this video is on more of the chain rule, as you can see by the title. And if you happen to watch the previous video and/or read the directions on Classroom that said stop at the 20-minute mark, because I did this problem right here, and yeah, I totally messed it up. So we're gonna do it the right way this time. I'm going to do a U substitution. You don't have to, I think it's easiest, and since I'm the one doing the problem, I'm gonna do it the easy way. So I'm gonna say, let U equal the cosecant of x plus the cotangent of x. So if U is cosecant x plus cotangent x, then y is u to the -1. All right, so we're gonna do a dy du, a du dx, a, PQ, PL. What's a few letters among friends? Here we go. A dy du is -u to the -2. U is cosecant x plus cotangent x, so this is going to be negative quantity cosecant x plus cotangent x to the -2. Great. Du dx. Okay. So du dx is the derivative of cosecant, which is negative cosecant cotangent, and then plus the derivative of cotangent, and the derivative of cotangent is negative cosecant squared. All right, so dy dx is going to be equal to dy du, and I'm going to right away rewrite this. This is going to be -1, but this whatever you call it, this equation, simplification, expression, that's the word I'm looking for. This expression is going to go in there in a minute. So the denominator is going to be cosecant x plus cotangent x squared. Okay, so -1, I didn't put the 1, blah, blah. Okay, times du dx, and du dx is cosecant x, cotangent x, negative, minus cosecant squared x. All right, so all these negatives, when you distribute the -1, that all goes away. So I end up with cosecant x, cotangent x, plus cosecant squared x. So I'm going to factor this. So my dy dx, I'm going to factor out a cosecant, and that's going to leave me with cotangent plus cosecant all over cosecant plus cotangent, quantity squared, cosecant plus cotangent squared, which simplifies when you reduce. You get cosecant x over cosecant plus cotangent. All right. The next one I'm going to do is number 18. So this video is pretty much tons of practice of evaluating trig functions, their derivatives, using the chain rule. So it's going to get pretty complex now. So I'm going to do the next one, which happens to be number 18, which is 4 times the square root of secant plus tangent. Okay, I'm right away going to rewrite this. This is 4. I do not want to deal with a square root function in terms of like how it's written. I much rather deal with 1/2 power. Okay, I'm gonna do this one without a u substitution. Sometimes I do, sometimes I don't. There's really no rhyme or reason. Practice. the u substitutions, let u equal, that might be better for you. Others of you might think this is way too many steps. Okay. Please note though that in the homework, there's no way that you are turning in homework to me that goes from here to here with nothing in between. Yeah, that's not gonna cut it. All right, power is 1/2. Bring it down in front, times 4 would be 2. So 1/2 times 4 is 2. Times the function, which is secant x plus tangent x, and then decrease the exponent by 1, so it becomes -1/2. Now I have to take the derivative of what's inside, so to speak. So the derivative of secant is secant tangent plus the derivative of tangent, and the derivative of tangent is secant squared. Okay, so this becomes 2 secant tangent plus secant, and I'm gonna do two things at once here. I'm gonna rewrite this as a fraction, and I'm going to factor out a secant. So 2, take out a secant, and you're left with tangent plus secant. All over, and I'm going to write it as secant plus tangent to the positive 1/2. I'm not going to use a square root sign. And the reason I'm not going to use a square root sign, this is tangent x plus secant x. I'm trying to find a better color to use here. That doesn't really help me. This is tangent x plus secant x to the first. I'm not sure you can see that or not. Tangent plus secant, secant plus tangent, same thing, who cares? Subtract the exponents. So you get 1 minus 1/2, which is 1/2. 1 minus 1/2 is 1/2 positive, so it's in the numerator. 1/2 power is a root. So this becomes 2 times the secant of x times tangent plus secant. The order in which you write it doesn't matter. Okay, I'm going to do 2 more funky derivatives, and then we're going to do a problem where you're asked to find position. Okay, next one I'm going to do is number 26. This is number 26. And 26, it says R is the secant of 2 theta times the tangent of 2 theta. And you are asked to find the derivative of R with respect to theta. Find the derivative of this equation with respect to theta, which is a variable. Okay. So I'm going to do product rule. I'm going to do the product rule. So I'm going to show more steps. So this is going to be the secant of 2 theta times the derivative of tangent 2 theta. Or you could say dr d theta of tangent of 2 theta. And then I'm going to add that to the tangent of 2 theta times the derivative of the secant of 2 theta. Okay, so secant 2 theta. The derivative of the tangent of 2 theta. Okay, be careful that you don't drop the 2 that needs to come with this. So tangent is secant squared x. So secant squared 2 theta, x is 2 theta, times the derivative of what's inside, which in this case is 2. Okay. Tangent of 2 theta times the derivative of secant 2 theta, which is secant tangent, so secant 2 theta, tangent 2 theta, times the derivative of 2 theta, which is 2. All right, let's just multiply a bunch of things out. So secant 2 theta times secant squared 2 theta is secant cubed 2 theta. Tangent 2 theta times tangent 2 theta is tangent squared 2 theta times secant 2 theta. What did I say was tangent squared 2 theta? Times the secant of 2 theta. Okay, can you go more? Can you factor something out? Sure. Do you have to? No. So one of the biggest questions is, well, how do I know when I'm done? There's no reducing that can be done. There's no substitutions that you can do, like sine squared plus cosine squared is 1. Not going to help you. So is it wrong if you factor out a secant 2 theta? Of course not. It's the equivalent of when you have, like, whatever. You're doing some problem and you have 5x minus 10. Is that okay? Sure. Is 5 quantity x minus 2 okay? Sure. Not necessary. Okay, these last two that I'm going to do are going to take some time and they're pretty complex. So, you know, make yourself comfortable. It's going to be a biggie. Here we go. What about finding double primes? What about finding, like, so the first derivative of, The first derivative of position is velocity, but sometimes you want the acceleration, so you need to know how to find the second derivative. Sometimes you want to know the jerk, well, you know plenty of those, but mathematically, then you need to know how to find the third derivative, and so on and so on. So this one I'm going to do is number 32. And this one you're given that y is equal to 9 times the tangent of x over 3, so that's the given problem. And the directions say find y double prime. If you get y single prime wrong, then you're automatically going to get y double prime wrong. So let's make sure that we are taking our time. Okay, so the first derivative, dy dx, the first derivative is equal to 9. The derivative of tangent is secant squared x. So secant squared theta, but theta is x over 3, times the derivative of x over 3, which is 1/3. So this is y prime equals 3 secant squared x over 3. Let me just do a little side note. So the derivative of, like if you're given the cotangent of 16x, this right here is your u. So it's the derivative of the cotangent. Derivative of cotangent is secant negative cosecant squared x, and then you would take the derivative of 16x, which is 16. So it's the power page 156, the bottom of page 156. Now I want to find y double prime. Okay. Okay, so y double prime is equal to, so I'm going to rewrite this. Sorry, one little thing here. Leave myself a bit more room. Okay, so I'm going to rewrite y prime as 3 times the secant of x over 3 squared. That's just going to make it a little bit easier for me. Okay, here we go. Power rule. 2 down in front times the 3. Maybe I should write that out. 2 times 3. Okay, the derivative of secant is secant tangent. So this is secant x over 3 times the tangent of x over 3. Okay. Okay, I skipped a step. Let me go back. I skipped a step. Okay, there we go. I jumped the gun. So 2 times 3, then the secant, the f of x, whatever it is, decrease the power by 1. Now take the derivative of what's inside. So the derivative of secant is secant tangent. So that's going to be the secant of x over 3 times the tangent of x over 3 times the derivative of x over 3, which is 1/3. Okay, so let me step through that again. Chain rule. 3x squared. Chain rule, 2 times 3 is 6, and then you make it x to the first. So that's where this came from. 6, this is my big fat x to the first. Now take the derivative of what's inside. So now the derivative of what's inside is secant tangent, x over 3. And then I had to take the derivative of x over 3, which is a third. This ends up being 2. You've got secant x over 3, which is secant squared x over 3 times the tangent of x over 3. You don't need those extra parentheses. And there you have it. Okay, so the last one I'm going to do is number 42, and this has to do with positioning and all kinds of stuff. All right, so this is 42, which is on the homework that will be assigned on, let's see, the 19th, 20th. All right, here we go. Number 42 says, find the equation of the line tangent to the curve at the point defined by the given value of t. Okay. So 42, we have two different equations. We have x is equal to the sine of 2 pi t, and you have y is equal to the cosine of 2 pi t. This gave me some trouble when I first did the problem because on the unit circle, x is cosine and y is sine, and then I was doing the problem later and I was like, I don't know what happened. Why are all the sines and the cosines mixed up? But on the unit circle, x is cosine and here y is cosine. So it doesn't necessarily have to do with an angle on the unit circle. It has to do with different curves. So you can have like y equals the sine of 2 pi and you graph it, and even though x is cosine and y is sine, I'm speaking in tongues. Just be careful with your sines and your cosines. I probably just confused you more than I helped you. All right, here we go. So I have two functions. How am I going to find a derivative at two functions? All right. So what if I want to find dy dx? What if I want to find dy dx? Well, I want to find the derivative of this function in terms of that function. Like, how does that work? Well, it's the same way that we do it with the chain rule. You can use u's and v's and all kinds of wonderful things. So this is going to be the equivalent of the derivative of the y function in terms of t over the derivative of the x function in terms of t. And when you simplify that, don't you get dy dx? You sure do. So just like for train rule, when we kind of went about it in a roundabout way, same thing here. I'm trying to see if you can see this. Like this is a previous problem where I wanted to find dy dx, and I found dy du, du dx for a total of dy dx. Same exact concept here. Dy dx is going to be dy dt over dx dt. Okay, so first thing I'm going to do is find dy dt. First thing I'm going to do is find dy dt. Okay, so the derivative of cosine is negative sine 2 pi t times the derivative of 2 pi t, which is just 1. I'm sorry, which is t. The derivative of 2 pi t is t. 2 pi is a number. Okay, and then I'm going to find dx dt, and the derivative of sine 2 pi t, the derivative of sine is cosine, 2 pi t, times the derivative of 2 pi t, which is t. Okay, so dy dx is equal to dy dt, negative 2 sine 2 pi theta, 2 pi t over dx dt, which is t cosine 2 pi t. So sine over cosine is tangent. And let me just show all the steps. This becomes negative t sine 2 pi t over t cosine 2 pi t, which is negative tangent of 2 pi t. Okay, so that's the first thing we need to do. It says find the equation of the line tangent. Well, okay, tangent, that means the slope of the tangent line is the derivative, and that's what we're doing right here. All right, to the curve defined by t. Great. So derivative, slope of the tangent, here we go. This is step 1. The next step is that they tell us t is negative 1/6. Okay, so if t is negative 1/6, this represents the slope. Negative tangent 2 pi t is the slope. So here we go. Plug in negative 1/6. So this is the negative tangent of negative pi over 3. This ends up being in the first quadrant. If you use your even odd properties, this ends up being the tangent of positive pi over 3, which is root 3. So this is your slope. Okay, but I also need to know what's the specific point. So x is the sine of 2 pi t, but t is negative 1/6. Y is the cosine of 2 pi t, but t is negative 1/6. So we're going to plug in. So x is the sine of 2 pi times negative 1/6. Y is equal to the cosine of 2 pi times negative 1/6. Okay, so the sine of, I believe this is negative pi over 3. This is the cosine, negative pi over 3. That's negative 60 degrees. This is negative root 3 over 2. Fourth quadrant sine's negative. This is fourth quadrant, cosine's positive. This should be 1/2. Cosine 60 is 1/2, yeah. All right. I know my slope. I know my ordered pair, point slope form. Y minus 1/2 equals m, which is √3, times x plus √3/2. So do the math, haha. Distribute, you get √3x. And then √3 times √3/2 is 3/2 plus 1/2 is 2. All right, and that is all of section 4.1.